So this lesson is more examples of logarithmic differentiation. So here we're going to say that f of x is log base 3 of x. And our goal is to find the derivative. And our goal is to find f prime of x. So again, I want to use the logarithmic definition approach with implicit derivatives. So I'm going to rewrite it as y equals log base 3 of x, and my goal then is to find dy dx that's equivalent. Now you can memorize the form for log base 3, but I prefer to go back to first principles. If log base 3 of x is y, then the base is 3. Then 3 to the y equals x. And now we want to use logarithmic differentiation to determine what the derivative is. So we're going to take the natural log of both sides. Natural log of the left equals natural log of the right. So natural log of 3 to the y equals natural log of x. And this enables us to bring the constant down front. So y times the natural log of 3 equals natural log of x. Remember, our goal is to find dy dx, which is the derivative of log base 3 of x. So we're going to take the derivative with respect to x of both sides. Derivative with respect to x of the left is the derivative with respect to x of the right. Now, log 3 is a constant. What is it? Natural log 3 is about 1.0986. That comes out in front of that derivative operator. So I have natural log 3 times the derivative with respect to x of y equals the derivative with respect to x of log x. Remember, the derivative of log x is 1 over x. Now, what about the derivative with respect to x of y? What is that? Well, that's our dy dx. So we'll say natural log 3 times dy dx equals 1 over x. I write it in parentheses just so we're clear on the notation. Then I need to divide both sides by natural log 3, divide the left side by natural log 3, divide the right side by natural log 3. So we get dy dx equals 1 over x divided by log 3, which is 1 over x times 1 over log 3. And we get our derivative dy dx equals 1 over x times the natural log of 3. Or if you like, going back to our original notation, that's f prime of x, right? We said f of x was log base 3 of x. So we conclude by saying f prime of x is 1 over x times the natural log of 3. Now, I would like to check this on my graphing calculator if I can. So I'm going to go ahead and I'm going to plug in that value, take its derivative, and see if what I believe the answer is the same as what the calculator tells me the derivative is. Let me go ahead and pull up the calculator. So we will start from scratch here. Our function is log base 3 of x, which, where do we find that? It's under math, maybe. There it is, log base. Y equals log base 3 of x. And I am interested in its derivative. So we're going to go to math button again. And deriv is number 8. With respect to x of the function y1, vars, y vars, function y1. Whoops, not there. Here, vars, y vars, function y1 at every point x when x equals x. So the red graph will be the derivative of log base 3 of x. So let's turn that off and let's do a zoom decimal maybe. And the red graph is the derivative of log base 3 of x. Now, what do we think it is? We thought it was 1 over x times the natural log of 3. So let's plug that in, and let's see if that graph goes on top of it. So we take 1 divided by parentheses x times the natural log of 3. Watch your order of operations. And this will be in black. So the black graph should graph on top of the red graph. If it does, I've done it correctly. And it almost does. Notice this black part over here has a different domain. But the black graph did go on top of the red graph here. What is our difference? What is our difference? Well, 1 over x log 3 is defined for all real numbers. But this function is only defined for positive values of x, right? You cannot take a log of 0. You cannot take a log of a negative number. So our derivative is only defined on positive values. So as you can see, our derivative function, the red function, is only defined on positive values. But if I turn the black function on, the black function is 1 over x times log base 3. That would also be defined on negative values. So on the relevant domain, the two graphs are the same, even though there is a minor difference in terms of looking at them that way. All right, let's take a look at another problem. This time I want to look at f of x equals 3x squared plus 1 to the sine x power. So again, I'm going to call it y equals. And the goal is to find dy dx, whereas our original goal was to find f prime of x. But they're equivalent ideas, of course. So we're going to appeal to the log again. So we're going to take the natural log of both sides. Natural log of the left side equals the natural log of the right side. So natural log of y equals the natural log of 3x squared plus 1 raised to the sine x power. And of course, the exponent can come down in front of the log operator. So we have natural log y equals sine x times natural log 3x squared plus 1. And at this point, we're going to use an implicit derivative by taking the derivative with respect to x of both sides. The derivative with respect to x of the left side, the derivative with respect to x of the right side. So the derivative with respect to x of log y is the derivative with respect to x of sine x times the natural log of 3x squared plus 1. All right, well, how about the derivative with respect to x of natural log of y? The derivative with respect to x of natural log of y. What is that going to be? The derivative with respect to x of the natural log of something is 1 over the something times the derivative with respect to x of the something. Our something here being y. So the derivative of natural log y is 1 over y times the derivative with respect to x of y. 1 over y. The derivative with respect to x of y is dy dx. So this first part here is 1 over y, dy dx. Now what do we have to do? We have our second part. We have the derivative with respect to x of sine x times the natural log of 3x squared plus 1. That is going to require the product rule, where we're going to say u is sine x. V is the natural log of 3x squared plus 1. U prime is the derivative with respect to x of sine x. So u prime is cos x. No problem there. V prime is the derivative with respect to x of the natural log of 3x squared plus 1. We know the derivative of the log of something is 1 over the something. So what I'll say is I will say the derivative of the log of something is 1 over the something times the derivative of the something. 1 over the something. 1 over 3x squared plus 1 times the derivative with respect to x of the something. What does that give me? V prime is 1 over 3x squared plus 1 times 6x or v prime is 6x over 3x squared plus 1. So we've done all of that, but then what do we have to do? Then we have to find the derivative using the product rule, right? uv prime is u prime v plus uv prime. U prime v cos x times the natural log of 3x squared plus 1 plus u sine x times v prime, which is 6x, over 3x squared plus 1. And that's what goes here. So as you can see, that's quite a bit to write. Cos x, which I'll put in parentheses for clarity, natural log 3x squared plus 1 plus 6x times sine x over 3x squared plus 1. And we're almost finished. We're almost finished. What do we have to do? Multiply both sides by y. So if that's the case, dy dx equals y times all of this, cos x times natural log 3x squared plus 1 plus 6x sine x over 3x squared plus 1. And the last thing I need to do is I need to replace y with what y is. Remember, we saw y way up here on top. Y was 3x squared plus 1 to the sine x. What is that going to give us? Dy dx equals 3x squared plus 1 to the sine x times all of this cos x times natural log 3x squared plus 1 plus 6x sine x over 3x squared plus 1. And I'm sure there are many equivalent ways one could write this, but I think that is good enough for me. No reason to do much else with it. I do encourage you to check it on the graphing calculator. You could imagine that's going to be a substantially challenging enterprise to keep the order of operations straight, but I think it's worthwhile to try, so I encourage you to do that. Still going with one more problem. I will do the following. I'll say g of x is the square root of e to the 5x plus 8x. My goal is to find g prime of x. Again, I'm going to rewrite it in terms of y. Y equals the square root of e to the 5x plus 8x. And now my new goal will be to find dy dx. And I'm going to rewrite this as y equals e to the 5x plus 8x raised to the 1/2 power. Let's take the natural log of both sides first. Natural log of the left, natural log of the right. Natural log of y equals natural log e to the 5x plus 8x raised to the 1/2 power. The 1/2 power comes down in front. Natural log of y is 1/2 times the natural log of e to the 5x plus 8x. At this point, we are able to take the derivative with respect to x of both sides. Derivative with respect to x of the left side and the derivative with respect to x of the right side. So the derivative with respect to x of log y equals the derivative with respect to x of 1/2 natural log e to the 5x plus 8x. Now, how do we do these? Well, the first thing we have is the derivative with respect to x of natural log y, which we've done multiple times before. the derivative with respect to x of natural log something is 1 over the something times the derivative of the something. So the derivative with respect to x of natural log y is 1 over y times d dx of y, which of course is 1 over y dy dx. Left side, 1 over y dy dx. Right side, well, let's pull that 1/2 out in front first. So the 1/2 comes out in front, and we get 1/2 times the derivative with respect to x of the natural log of e to the 5x plus 8x. And we need to do that one next. So the derivative of the log of something is 1 over the something times the derivative of the something. So we have here, we have the derivative with respect to x of e to the 5x plus, oops, I lost the log sign. Let's try that again. The derivative with respect to x of the natural log of e to the 5x plus 8x. The derivative of the log of something is 1 over the something times the derivative of the something. So it's 1 over e to the 5x plus 8x times the derivative of e to the 5x plus 8x, which is 1 over e to the 5x plus 8x times the derivative of the sum is the sum of the derivatives. So the derivative of e to the 5x plus the derivative of e to the 8x. And then what do we get here? So now I have 1 over e to the 5x plus 8x times. What's the derivative of e to the 5x? Well, let's talk about it. What do we know? We know the derivative of e to the x is e to the x. We know the derivative of e to the something is e to the something times the derivative of that something. So the derivative of e to the 5x is e to the 5x times the derivative of 5x. So that's e to the 5x times 5. The derivative of e to the 5x is e to the 5x times 5, or 5e to the 5x. Plus the derivative of 8x is just 8. And then I can write this as a single fraction, 5e to the 5x plus 8 over e to the 5x plus 8x. All of that was the derivative of the natural log of e to the 5x plus 8x. So I will make that substitution over here. So this is where we are currently. 1 over y dy dx equals 1/2 times. The derivative of this was 1 over that, right? 1 over that was e to the 5x plus 8x times the derivative of that, which was 5e to the 5x plus 8. Now we're not finished because I've got to multiply both sides by 5. So my next step is to say that dy dx equals y times all of this stuff. Y times 1/2 times 5e to the 5x plus 8 over e to the 5x plus 8x. What was y? Way on the top of the page, we can see what y was. Y was e to the square root of 5x plus 8x. So making that substitution, dy dx is the square root of e to the 5x plus 8x times all of this. Notice 1 times that on top. I'll just leave that on top. 5e to the 5x plus 8. Downstairs, 2 times all of that, which I'll just probably leave it that way. 2 times e to the 5x plus 8x. And that is our final answer. Again, I would encourage you to check that on the calculator.